Hello and welcome to a very special episode of NASA Science Live. I'm Felicia Chow from the Office of Communications, and we are here live at NASA's Goddard Space Flight Center in the world's largest clean room. More recently, this clean room was used to house the James Webb Space Telescope, but right now it's holding something a little different: NASA's next steps to send science to the moon. Behind me are exact scale models of actual landers that 3 American companies are sending to the moon bearing NASA science. Let's hear some words from our administrator on this exciting announcement.
The Artemis program is pressing forward to the moon, and science is leading the way. We go to inspire generations and to bring home ideas and discoveries that will benefit all of humanity. To do this, we must better understand the makeup of the moon. We must study areas of the lunar surface where no human or rover has ever been before. Today we announce an initiative that further demonstrates how this effort is unlike any before it. Today, NASA becomes a customer of commercial partners who will deliver our science instruments and our lunar technology to the surface of the moon. This is a crucial step in our ongoing success. NASA is proud to announce that the first commercial payloads to the lunar surface will be provided by Astrobotic, Intuitive Machines, and Orbit Beyond. These companies are prime examples of American ingenuity, vision, and know-how. Because of these landers and the instruments they deliver, the science, technology, and research that will be done in the immediate future will prepare the way for humanity's return to the moon by 2024. We are going.
Thank you to the administrator for that inspiring message. Joining us today is Dr. Thomas Zurbuchen, who is the Associate Administrator of NASA's Science Mission Directorate. So Thomas, can you tell us why this clean room is so important and why we're not in bunny suits right now?
Well, you said it. This is truly a historic site for NASA. In this very room, the Hubble Space Telescope was assembled, a science machine that is still productive today. In this room, last time I was here, actually through that window up there, I looked in and I looked at the mirrors, the super polished mirror of the James Webb Space Telescope. So the room is being prepared for the next mission, and we have time right now to use it for this other historic announcement that is driving today.
That is incredible. And can you tell us a little bit more about the announcement?
So this is truly exciting, a new way for us at NASA to do business. It's an announcement about partnerships, partners, private sector partners, for which that we will work together with and go to the surface of the moon, because we can't wait to do the science that we want to do with instruments that we're developing right now. Science that in many cases, even 5 years ago, we didn't know how to ask questions about. This is how urgent this is.
That is so incredible, and this is such an exciting time for NASA science. Like, these companies are the ones who will be building these spacecraft to land on the moon with these science instruments. So we have company representatives from each of these 3 companies, and they're full-size, life-size landers. So let's definitely go take a look. Now, if folks at home want to ask questions via social media, please use the hashtag AskNASA. Here we have Astrobotic CEO John Thornton and Mission Director Sharad Bhaskaran. So, Thomas, what do you think about this model?
So I'm really excited to meet you, and of course I know about your company. Tell us about the company, what drives you to go to the moon?
Today is an exciting day for us. We're so thrilled to have NASA joining our payload manifest to go to the moon. This actually, NASA's 14 payloads, plus the 14 payloads we already have booked for the flight, make it 28 payloads that are going to go on our lander up to the surface. So this is a great day for the lunar commercial payload delivery market, a great day that shows that NASA is now going to be a major part of the future of the moon.
Really excited. Where is your company located?
We're in Pittsburgh, Pennsylvania. And we're there because it's the world's best robotics, and we import space, and best space robotics in the world pops out.
Wonderful.
So let's take a look at your lander. Can you tell us what went into the design of this lander, and what are these big gold Easter egg looking things?
Yes, so the Easter eggs are actually propellant tanks, and this represents the blankets that keep those tanks warm during the mission. The propellant tanks contain the propellant that will power our spacecraft to the moon. There's actually a helium tank inside in the center, and that pressurizes the system, and then the propellant goes into the main engines and the attitude control system to control the spacecraft.
When do you expect to leave to go to the moon?
Yes, we're going to launch in June 2021, and we'll land in July 2021.
Really exciting.
That is very cool. So tell us a little bit about it. So how tall is it? How heavy is it?
Yeah, this is a full-scale representation of the spacecraft, so it's about, as you can see, 6 feet high. And when it's fully loaded with propellant, it'll be about 1,400 kilograms.
1,400 kilograms. That is really, really heavy. So what makes this lander the perfect lander for you guys?
Yeah, so I think this is the perfect lander because we are a very customer-focused design. So we have open decks for payloads that can mount on the top and the bottom. And so that's been our motivation, to make this as customer-friendly as possible and to carry the maximum payload mass. And we made it, we had a lot of rigor in design. We follow a very standard process to make sure that we have a lot of controls and checks in place during the whole development effort. So we think this is a very customer-focused and low complexity design to minimize risk for the program.
So I know there's a lot of scientists watching right now because they want to get payloads to the surface of the moon. Tell us where these payloads will be located. Just
right,
point
so
to it, please.
what you're seeing is the payload decks, and so we can mount payloads to the top here, we can mount to the bottom, like rovers would mount to the bottom and then deploy. We can mount things up here to have a direct line of sight to the Earth or to other objects in the sky. We can also, in some cases, mount to other surfaces as well, but the payload decks are the primary location where we mount all our payloads.
Okay, great. Well, thank you so much.
Thank you so much.
Let's go check out the next lander. So after this event, we will have a media telecon with all our guests and reporters to ask questions. To tune in, go to nasa.gov/live. So we have Intuitive Machines Executive Chairman, Dr. Kam Ghaffarian, and Dr. Tim Crane, Vice President of Research and Development, joining us.
So you're from Houston, is that correct? So tell me about what motivates you to go to the moon.
Yes, so I was 11 years old when I saw for the first time Neil Armstrong stepping on the moon, and it inspired me to be part of the space program. And this is really a dream come true today, being here. And by the way, I want to give a shout out to all the people in Houston that made this happen. And so I've been part of the space program now for 37 years, and company about 7 years ago with some former NASA employees, and you know, we've been involved in the space program for a long time. It was our love and passion, and we're just so grateful and appreciative to have this opportunity with NASA as our partners to be able to have the opportunity to land on the moon and carry
Tell
cargo.
me about the business, you know, so we're a customer, of course. Tell me about how you're thinking about this as a business.
I think this is terrific. I think commercial space in general, I think is a beginning of a new era, and especially going to the moon and opening it to the commercial companies to compete. I think it's a new era, and it's going to create a new ecosystem in a commercial space, and I think that's wonderful for industry.
That is very cool. Can you tell us more about this humongous lander?
You bet. You've noticed we have the tallest lander. There's several systems on this lander we're very proud of. The first is a liquid oxygen, liquid methane propulsion system. And so one of the tanks carries cryogenic oxygen and the other tank carries cryogenic methane. And they go through the Moorhead engine on the bottom, which we designed in Intuitive Machines. And it's a throttleable engine, which means we can control the thrust level very, very smoothly and adjust for different weights and different landing locations. We also have a precision landing and hazard avoidance system on board, so we can avoid craters, rocks, slopes that would otherwise harm the vehicle. And the barrel truss structure is actually where we can mount payloads. So we don't have a payload bay or a single payload location. It's really up to our imagination and the needs of our customer to find the right place anywhere on this barrel structure to mount their payloads.
So when do you expect to go to the surface of the moon?
We are going to launch in July of 2021, and after 6.5 days, we will land on the surface of the moon.
That is amazing. So I see these giant solar panels too. Can you tell us more about how this lander is powered?
Absolutely. So one of the things we do as a service to our customers is not only do we deliver the mass to the moon, we provide power and data services as well. And so during transit, the solar panels on the side help us to generate power to keep payloads alive or to operate them on the way to the moon. And then once we land, we have solar panels on the top deck as well, so that we can basically be a power station for any mounted payloads or rovers or anything that deploys.
That is very cool. So can you tell us a little bit about the silver kind of globe-shaped things also?
Right, those are our tanks.
Those are
And
the tanks.
these are cryogenic tanks. So we keep our propellants very, very cold so that they're very dense and we can carry more propellant in the same volume. And then that gives us a very high performance for the vehicle to put up to 100 kilograms anywhere on the surface of the moon.
How do you keep them so cold?
Well, we manage basically our exposure to the sun and our exposure to the vacuum of space, and we watch that very carefully. One thing we do is we hide behind the solar panels, so we use the sun for power and we shade ourselves with the solar panels.
Really cool.
Okay, yes. And final question, how do you think NASA's return to the moon will affect the space industry and commercial partners like yourself?
Well, I think this is, like I said, amazing, and I think it not only impacts the industry, but I think it will create a new era where, you know, the children in school like I was going to be inspired to join the space program and start exploring the space. So I think it's incredibly exciting, not only for industry, I think it's exciting for NASA, and I think it's exciting for American people.
That's so wonderful. Our last lander.
so
So,
much.
want to learn more about our commercial partners that will be sending these payloads to the moon? Go to go.nasa.gov/moondeliveries. And here at Orbit Beyond, we have President and CEO Siva Patti and Chief Science Officer John Morse joining us today. So I heard that you brought your engineering model.
Yes, it's our engineering model.
So I'm really excited about getting to know your company better. Tell me about your company and what motivates you to go to the moon.
Excellent. So Orbit Beyond is a cislunar transportation company that carries payload to the cislunar ecosystem. We have brought together a consortium of partners that leverage on each other's capabilities and expertise and synergistic technologies, along with a management that brings in entrepreneurial and commercial management that can foster us to achieve our objectives in reaching this cislunar mission. The reason that we are looking at, I'm excited about the cislunar space, is that it is getting commercialized, and with the reduction, the lunar market is going to grow exponentially in the next 10 years, and with the reduction in cost in the cislunar payload, there will be a lot of investment that will get into this space for creating in-space infrastructure to create new markets in exploring and utilizing space resources. Orbit Beyond's vision is to be a key player in the in-space ecosystem.
So tell us, if everything goes exactly like you hoped, when are we going to be at the surface of the moon with this?
September 27, 2020.
Wow.
That is
That's
really
really quick.
Yeah. So can you tell us a little bit more about your lander?
Yeah, you mentioned it's an engineering model. We'll make some design adjustments based on all the testing we've had, like making the legs a little further out for stability reasons, but it's essentially, this is the size of the lander, and it's been through all the testing that we've done. It's been stripped of some of the components now, but this is essentially what we're going to have with the solar panels on this side. We're able to have science instrumentation on the top deck, on the mid deck, and even on the bottom, where we have navigation cameras which will take pictures of the descent. It'll do hazard avoidance, and from these middle areas here you can have instruments that look out or look down at the lunar regolith to see what the resources are there. We can also look up from the top deck, because we're not only exploring what the moon is and where it came from and how to sustain there, but also it's a great view of the cosmos for certain instruments as well.
So there's a little passenger here which you brought, just like all the other partners here. You have other customers as part of that. You want to talk about this?
Exactly. So we have several NASA payloads and several commercial payloads from our commercial partners, and one of them is we as a company and our commercial partners, Ceres Robotics, want to demonstrate mobility. And so this is a demonstration rover. It's on the other side of the lander here. There's a little garage on the other side, and when we land, the rover drops down and off it goes. It's got a stereoscopic camera, and we may have other types of sensing devices on it, but it's for us as a company, along with learn about how to do surface mobility and operations, so that later the lander can scale up larger and the rover can become larger and accommodate more complex and ambitious instruments.
Of course, at NASA Science, we're really excited about surface mobility as well as sample return, all of which is in the future.
Mm-hmm.
So can you tell us what inspired you guys to kind of get into the space business?
Oh, I remember distinctly in 5th grade. I mean, I'm a child who followed all of the Apollo missions, and I love that our design reference mission for this lander, which is called Z01, and we're going to have a naming contest. Z is the Z-axis because it's a lander, but we're going to have a naming contest later about what we can name the lander and maybe even our commercial rover. But you know, my favorite mission was Apollo 15 because they had a car, and it went to Mare Imbrium. We're more in the middle. Apollo 15 was on the side, but we've got a car too. And then I remember, because I always want to tell my parents how much I appreciate how they gave me a telescope when I was in 5th grade, and in one night I saw the rings of Saturn, the phases of Venus, and the craters on the moon, and that's what got me hooked.
That is so incredible, and thank you so much. So Thomas,
do you mind if I just, the one thing
Yeah,
I didn't
sure.
ask you yet, you know, is the location of your company. Tell us quickly about that.
So we are based in 2 locations. We are headquartered in New Jersey, and we have a location in Daytona, Florida.
Wonderful. Well, thanks so much. Didn't
Thank
want to
you
miss
so
that.
much.
Yeah. All
Yes.
over the
So
US,
Thomas, we have just seen some incredible landers and all the companies that will be sending them to the moon very, very quickly. So what is it that we're trying to accomplish here? What is our main goal for these delivery services?
The most important goal that we have right now is really science. That's what drives us in the Science Mission Directorate. But we do so as part of the agency strategy to go to the moon with the first woman with the next man, Americans to the surface of the moon. For that, what we want to do, of course, is not to do it the way we did it the first time, alone. We want to do it with partners. And the commercial partnerships that we have here represented with these 3 partners that we're bringing on board are the types of partnerships that will be symptomatic for everything we do. We want to not only go there, but grow an industry, because that's the only way we can stay. International partnerships are just as important. Do this in partnership. So this is the fastest part of that campaign. It's a campaign that is driven by science, but is part of a much broader picture that is driving us all at NASA.
Definitely, and that is so inspiring and so exciting. So we're going to transition to the Q&A session. For folks at home who want to ask questions, please use the hashtag AskNASA via social media. So we're going to go ahead and ask some of the questions we have already here. Mani on Facebook, which kind of experiments are you going to do on the moon with these spacecrafts? So let's just go ahead and
Why
go
don't I
around.
start with experiments?
Yeah, sure.
There's some experiments, and I want to definitely hear their opinions too, but the experiments that we're funding out of NASA that right now are being developed in various locations, there's more coming. Those experiments are focused primarily first on volatiles, you know, like water and other parts of the moon. Frankly, we've only learned about in the last few decades, because during the Apollo era, we thought the moon was really dry. Well, we know there's a water cycle there. We want to go explore that for science reasons, but also because we have the suspicion that we can use those as fuel and as to sustain life once we're there. We also want to explore the moon itself. There's many questions about nature, the solar system, that are addressed right there at the surface of the moon. For example, the exact age of the solar system and important periods that were really violent periods in the past, like the bombardment, a phase in our solar system that scarred the Earth, but of course also scarred the moon. The Earth is all gone because of erosion, because of the geology. The moon is still there. We can go learn there. Of course, we want to learn about the environment because we want to bring our fellow humans there, and so experiments do all that. But what is exciting to you?
In addition to NASA's 14 payloads that are going to be on our mission, we have another 14 payloads. That's a whole array. We've got science instruments. We have rovers that want to go off and drive and explore the surface. We even have companies that want to do things to inspire their audiences. We actually have some groups that are looking at building lunar infrastructure. So we've got one payload in particular that wants to build a laser communication system to go from Earth to moon. So orders of magnitude more bandwidth. There's just a whole array, and we're actually bringing 8 other nations with us on the first mission. So we're really making the moon accessible to the world.
Go for it.
The science is exciting. We're also doing some engineering to enable safer and more regular access. We're carrying a NASA laser landing system that will allow precise, safe landing. We also have a commercial landing system that we're carrying and advancing for another company. So we think that the science is exciting, but also the ability to move the engineering forward and to improve our systems so that we can do more regular lunar access is exciting as well.
And on Orbit Beyond's lander, I already talked about the mobility that we hope to demonstrate. We also have the NASA payloads who are concentrated on understanding how the landing itself can disturb the environment, so that when we make assessments of the environment in the vicinity of the landing, we know what might come from the spacecraft. And then we also have on the top deck these laser retroreflectors. You know, all the missions will have them. And so this is so that we can pinpoint our location very accurately. And we can do this from lunar orbit and also from Earth observations.
So, from Scott from Twitter, do we know what launch vehicles each of these landers are going on?
Go for it.
We do. We're planning to use SpaceX Falcon 9.
How about you?
Guilty as charged, SpaceX Falcon 9.
How about you?
And we're going to be assessing our launch options and making a decision very shortly, so stay tuned.
All right.
So what do each of these companies feel is the biggest challenge in going to the moon? Let's go starting alphabetically.
So one of the biggest challenges is the moon is not super close. It's about a quarter million kilometers away from Earth, and that's challenging to get out there. You got to survive the environment. You got to survive the radiation. Once you land on the surface, the lit part of the moon can get up to 120 degrees Celsius, or about 250 degrees Fahrenheit, and that's pretty hot for these spacecraft. And then the landing itself is super critical. You're flying very, very fast out towards the moon. You've got to drop and descend into lunar orbit and descend for a nice soft landing down on the surface. So for all of that challenging environment, we build a very robust, proven lander with proven components so that we can get it right the first time.
The great thing about where we are today is the technology to build spacecraft is so advanced and available commercially. We have a great toolbox to choose from, but it's the integration of those systems that'll work for the lunar environment and in a fully automated sense. That's the real challenge. And then doing it in a way where we're commercially viable so that NASA is one customer among many, that's where the challenge is for us.
Right, and I'll echo that. There's the technical challenges and then what we can call a programmatic or commercial challenge. We want to execute this mission, but we're always keeping our eye on the missions in the future, attracting new customers, keeping our costs down and affordable, being global in our appeal, and attracting as many people as we can into the cislunar ecosystem.
So, Thomas, very good question here from Philip on Twitter. Will there be more rounds of CLPS selections?
That's an easy answer.
Right, and just to clarify, CLPS is Commercial Lunar Payload Services.
The type of selection that we are
Yes.
announcing today. The answer is yes.
Excellent. And so for the rest of the companies, what will the landing process look like for each of these landers?
So our process will begin with orbiting the moon first and checking out all our systems to make sure we're ready for landing. And then once we have gone through that checkout, then we're going to begin our descent sequence where our landing sensor will come on. and make sure we're at the right altitude and the right speed. And then slowly we'll come down and our main engine will be firing the whole time. And then we'll come down to a vertical orientation, and we'll make sure that we're at the right landing site that we've pre-selected, and then make a soft landing. And then once we make a soft landing, then we begin all our payload operations. All the payloads that you talked about will begin their operations. Rovers will begin deploying, booms begin deploying, and that's when the fun starts.
A very similar story. The physics of the moon drive you to a set of solutions. We'll enter lunar orbit. We'll check all the systems out. We'll use the lunar surface to improve our navigation solution. And then we begin a braking maneuver to basically remove the energy from our orbit to approach the landing site. Before we get to the landing site, we do a scan for safe locations, for, again, rocks and boulders, hazard detection. And then we'll approach and hover 30 meters over the landing site and go into a vertical descent. And so that gives us plenty of space to make sure everything is nice and stable for that final landing sequence.
And similarly, we go to the moon directly off our launch, and we go into lunar orbit for a couple of weeks, and we gradually bring the lunar orbit down till where we're just a dozen kilometers or so above the surface, and then we start. It's an autonomous landing, and it has the capability with its environmental assessment of avoiding hazards on the way down. But once we trigger that sequence, it's in the hands of the spacecraft.
Excellent. And we have two questions from reporters asking about locations. So the first one is Leo Enright from Iris TV. There has been a lot of talk in recent years about the Shackleton crater. Is this a likely target for the first mission, or are there other candidates?
Do you mind if I just, before they talk about their own,
sure.
just tell us what their philosophy is? You asked earlier whether we will have more selections. Of course, part of the reason for that is there's a number of locations we want to go to. So we'll have a maximum of 3 here. And in every case, actually part of the proposal that was submitted had location identified. We will now work with the companies and actually look at options just to make sure that we maximize as a system what we're doing. But you should talk about what if you took off today, where would you go?
Right. So our first mission is going to a place called Lacus Mortis. It's a crater, and there's a pit of scientific interest near where we're landing. But we selected a nice, smooth, flat plane, mainly because landing is the most important thing on the first mission, to prove that we can do that, and the spacecraft can do that. But in the future, our spacecraft can go to any location on the moon with minor changes to the spacecraft. So we can go to craters, pits, equatorial, polar regions, and we're excited about those future missions to do all those interesting things in science.
Similarly, the Nova C lander can land anywhere on the moon, but as you know, the moon goes through phases, and what we see as the phases of the moon from Earth is basically the sunrise moving across the moon. Since we're solar powered, we target most of our landings to be in the lunar morning, so we'll have the maximum amount of solar power for the lander. And we're evaluating 2 candidate locations right now, one at Oceanus Procellarum, the Sea of Storms, which is on the western side of the moon, and another one at Mare Serenitatis, which is the Sea of Tranquility, just east of a previous landing, which is Apollo 15.
And for Orbit Beyond, as I mentioned, we have a design reference mission where we're landing in Mare Imbrium. And we have a specific location picked out with a roughly 2-kilometer landing ellipse. And these are the vast lava plains of the Sea of Rains. One of the things I wanted to point out is that we have been working with Brown University and Professor Jim Head and students on assessing this landing site and why it's scientifically interesting, and we're going to keep that collaboration going throughout the development and the mission.
One of the elements that I really want to mention here is that, of course, Lunar Reconnaissance Orbiter, which is a spacecraft in orbit around right now, is really adding value to all of these companies. In fact, what we're doing is providing the best data, all the data that we can about the various sites that are under investigation here and others that we might explore from that very valuable spacecraft. So I really look forward to supporting that with that NASA assets. That it's just it's a treasure trove of lunar science.
And speaking of lunar science, as you all know, NASA's Artemis program is kicking off, where we're going to send the first woman and the next man by 2024. So how does this work here help with that program?
So the most important thing we need to do to go to the moon is take off and start learning how to land, kind of bring our commercial partners with us, and actually, in fact, have them take over and us taking rides with them. So this is such an important part of really creating that set of partnerships that enables that creative partnership to the surface with our partners, our commercial international partners. It's a critical first phase. As we go forward, and we asked earlier, are we going to do more with the commercial initiative here? There very well are questions that we will ask to the companies in the catalog about options that we have that may want to we may want to use to go place something there, or even bring bigger payloads as we grow stronger with this community. So it's a critical part of it.
And once we start landing humans on the south pole of the moon, how do you think this work also benefits that?
Well, we really want to go land there first with robots, and so as we go forward, and you know exactly when Artemis is going to be there, it's in 24, right? So ahead of that time, we want to go explore where we want to land with our fellow humans and be ready for that, and know the engineering environment, know nature, the environment there, and really get ready for that exploring with robots. Robots and humans go together. That's the right way of exploring.
And talking about exploring, are there capabilities of hosting external cameras on your rovers?
On our spacecraft?
On your spacecraft, yes, sorry.
Yeah, absolutely. We have already cameras mounted on the spacecraft to do visual observations, confirm landing, and also to do science once we get on the surface. So we have capability to mount cameras also in many different locations on the spacecraft to get different views of maybe the sky, the surface, the ground, anything that PI wants to look at.
Absolutely. In fact, we're very excited about an academic payload we have, which is called EagleCam from Embry-Riddle University, which will be a camera which ejects from our lander during descent and takes an image of the landing. So we'll be able to capture images of a landing from a third-person perspective. We're very excited to see what we get from that.
And yes, we do have cameras. We hope to have stereoscopic vision with HD quality, and it's good enough not only to drive around and make sure you're navigating a good course forward, but being able to do assessments of the terrain that you're going over, and whether it's fine sands and soils or what kind of colors are coming off the rocks, etc.
So we all know that the moon is very dusty. So one of the Twitter questions we have from Astro and Music is, how will dust from the moon affect your landers, and also your cameras?
The dust is really unique on the moon. It's not like the dust here on Earth. It hasn't been softened by the weather on the moon, so all that the dust is actually really sharp on a microscopic level. And that's challenging because it sticks to surfaces. It's also somewhat electrostatic. So for the landing, a lot of that dust is going to be blown out sideways, but we actually do have some rovers that are going to be dropping and driving across the surface. And we need to make sure to travel slow enough so we don't kick up that dust and land it on our critical thermal surfaces. We also need to make sure to protect the lensing and any sensitive science instruments that might be affected by that dust covering. So it's very, very challenging, and I think it might be one of the challenges as we head to the moon.
Yeah, absolutely. Protecting optics is the first thing you worry about with the almost pumice-like dust that you get from the lunar regolith. It also affects our flight approach. So the terminal descent, that last 30 meters, part of that is there so that if our sensors get confused by the dust, we have plenty of time to control on inertial only and make sure that that dust doesn't cause a problem for our landing system.
And finally, ditto, we're concerned about all those things, but people want to understand, how close can you put a habitat to a landing site where maybe a cargo resupply vehicle is going to land and supply materials to astronauts on the surface for long duration habitation? And so when we do these descent and we get this imagery, the scientists and engineers can study the trajectories of those plumes and kind of understand what that radius is going to be around a landing vehicle.
So as we kind of move forward to putting the next woman and the first man onto the moon as part of our Artemis program, what would you tell the Artemis generation? Like, what would you tell them now to inspire them to get into the space industry?
This is a new era for the moon. It's been almost 50 years since we've been back as a country. Now we're going back, we're going to have regular routine access to the moon. It's going to be in ways that we've never experienced before. Our scientists are going to get really, really smart about what's up there. This is a whole new era, an incredibly exciting time to be joining space.
So I was that kid, and I got inspired by being in space, and I am here today. And I would tell them, go for it, because it's an incredibly exciting journey. Humans have our DNA where we want to explore, and this is a new frontier, and we really are the pioneers in that new frontier. So I think it's just be incredibly exciting, and I would encourage them to go for it all the way.
Dream big, back it up, and you will always achieve it. It's like my daughter says, aim for the stars and you will fall on the moon.
That is awesome. So I think it would be great to just kind of go around for everyone to kind of say, how excited is this announcement, and how do you think this is going to affect humanity in the next 50 years? We'll start with Thomas.
Well, I'm excited about the announcement, primarily because we're really finding a new way of doing business. So for me, that's a leap. It's a leap going forward. We look at launch, what has happened with launch. We have a different way of doing launches today than when I was a kid, right? So this is a new way of doing research of our moon, and a way that can scale to other places as well. So for me, as we're building that success, we're opening up doors that were never open to humanity before. So that's what's exciting to me.
We started Astrobotic 12 years ago with just a dream that maybe someday we could be here today, just on the precipice of a whole new era. And it's just so incredibly exciting. We've had so many bad days and good days over those 12 years, working really hard to build the pipeline, build the market, show that commercial delivery is possible. And here to have the most respected, largest space agency in the world give us a major contract to deliver those payloads is just, it's awe-inspiring and just amazing.
Tell you, we're just incredibly honored and privileged to have the opportunity to partner with NASA. This is, for me, is personally a dream come true. I was 11 years old when I saw for the first time Neil Armstrong stepped on the surface of the moon, and here we are with our company going to the surface of the moon. I think that's incredibly exciting, and I think it's going to create a new era, a new ecosystem for commercial companies to really explore space. And I truly believe that the commercial space in general, whether it's low Earth orbit or deeper space exploration, is just beginning and starting, and it's going to be a really, truly exciting journey.
We are very excited. This is really, NASA is providing a platform and opening up the cislunar market, and it's going to drive a lot of investments, innovations, and it is going to create a new frontier where there will be a lot of players coming in and to explore a new market, to explore space resources. So we are extremely excited to be part of it.
That is so incredible. And I want to thank you all for joining us today, and thank you all for kind of tuning in to this incredible historic announcement. For the first time in a decade, Americans will be in more than a decade, actually multiple decades, Americans will be landing spacecraft on the moon carrying NASA science instruments. And these three companies are going to be making it happen. So this selection is one of the first steps in our NASA's Artemis program that we kind of mentioned above. So if you're a member of the media or you're just at home and want to learn more about this, I highly recommend you tune into our Media Telecon at 2:30 p.m. Eastern Time, and you can do that online at nasa.gov/live. We are going.
Thumbs up, guys.
Yeah, thanks.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
this system is capable of being the catalyst for deep space missions. We need a capsule that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.